previously to this, we've discussed the ocean floor, period. And we know that the ocean floor is nothing but what? Land underwater. And it includes things, features like what? Mountains, trenches, ridges, valleys. We have all of those things. So in addition to the way that we are able to see those things underwater, and then I say see, I put those in quotations because we can't physically see them, and we do have technology that go down and see, but the way that we are able to measure the depth so that we can measure out or draw out the ocean floor for us to understand aquatic life and its relationship with land life, we have to measure the depth of the ocean floor. And the way that we measure the depth of the ocean floor is by using something called sounding or sonar. So if you want to highlight that on your paper, sounding or sonar. And up here it says, label the sea level, transmitter signal, receiver signal, and the ocean floor. So when we look here, what would this be considered, this arrow here? This would definitely be considered sea level. And what happens is the boat travels along sea level and it stops at various different locations along sea level. It's going to travel from coast to coast so that it can get the measurements of the ocean floor from coast to coast. And that's how we're able to tell that from one coast we have a continental shelf to another coast where we have another continental shelf. All right, so as it's traveling through these different locations, what's going to happen is the boat has sonar or sounding, which, what animals use that? Whales. How does that work when whales use it? They make a noise, okay? So they just make a noise to be annoying 8th graders or to communicate? Not there, but for this reason, for sounding, why are they making that noise? To know not just how deep the water is, but to know what? Not just other wells, but what else? Other animals, or what else? If this is a continental shelf, the edge of the ocean floor, do I want to be a whale and just continue? Do I want to do that? No, so I need to use what? They can't see. They can't see as well underwater, no. So what are they doing? They use signals, just like another animal on Earth. What is that? On Earth. Bats. What is that called? Echolocation. Now, someone explain to me what echolocation is or how does that work? No one knows? Bats can't see very well either. Exactly. The sound bounces off. So what happens is they'll send out a noise. That noise will then float from what they send out. And they're paying attention to see how long it's going to take for that noise to come back. If it takes a long time for that noise to come back, that lets them know that they're in a closed area or an open area. They're in an open area. But if that sound comes back very quickly, that lets them know that something is close. And that's how they do. That's how they are able to figure out their location. Sounding or sonar works the same way. The boat will travel along sea level. Not only a boat, also you may have a plane that flies in the air that also travels above sea level, and it sends a signal down at an angle through the ocean. And when it sends a signal, that signal, what do you think is called? This is the transmitter signal. It sends it down. And then it waits for that signal to bounce back. So that lets us know that that sound has hit something, and it's going to bounce back. When that sound bounces back, what is that signal called? This is your receiver signal. And this area down here is called your ocean floor. And then we use a calculation knowing the speed of sound. We use that information plus the calculation of how the time that it took for the sound to come back, and we measure the depth of the ocean floor, and that's how we're able to see how deep the ocean floor is at each location, and then we kind of draw it out using what we call a topographic map. And much of the ocean's topography has been mapped by the uses of these devices called sounding, and that's what this paragraph is telling us here. In this method of sounding, what I just described to you is we send down a signal. When that signal hits the ocean floor and bounces back up to us, we use the amount of time that it took for us to get the signal back, and the speed of sound that we know is 1,500, approximately 1,524 meters per second. And we use that information plus the amount of time it takes for us to determine how deep the ocean is. This is good for people, marine biologists. How many of you maybe want to be a marine biologist? Okay, that means studying life underwater. This is good for them because they need to know how deep they can go. They need to study where organisms live within the water and things of that nature. So, by using this information, we plug it in the formula and we find out the depth. What in this paragraph fits in this blank here? A blank is a two-dimensional representation of a three-dimensional surface. This is something that we draw out to be able to determine the ocean floor depth and show its features. Topographic, what kind of topographic? Map, or called topographical map or topographic map. And that's just a two-dimensional representation of a three-dimensional surface. When we draw out the ocean floor with its continental shelf and its trenches and its abyssal plains and its rift valleys and mid-ocean ridge, that's basically a two-dimensional picture showing us what a three-dimensional something looks like. Any questions for this? So let's become sonar detectors for measuring the depth of the ocean floor. Now, if you see a picture that has a boat floating along the ocean, sending signals and receiving signals, what is it measuring? Depth of the ocean floor. If you see a plane flying along the sky, sending a signal and receiving a signal in the ocean, what is it measuring? The depth of the ocean floor. They do the same thing. If they're sending a signal in the water and receiving a signal from the water, they're measuring the depth of the ocean floor. All right? So let us discuss that just a little bit further. The formula for measuring the depth of the ocean floor is D equals 1/2 T times V. D is your depth, and it's measured in what? Meters. T is your time, measured in seconds. Velocity is V, also known as the speed of sound in water, which I just told you was 1,524 meters per second. So meters per second basically means that you took that by taking D divided by T, also known as meters per second. So far, so good? Yes? Now on your paper, you have a blank location underneath this information here. You have some space. We're going to use that space to calculate some of these things. We're going to do the first one together. So what happens is, once again, is the boat travels along the sea level. It stops at a location, which will be location A. It sends the signal. It waits for it to come back. It says the time. It says it took 1 second to come back. It stops at another location along sea level, which we'll label location B because it's the second location. It sends a signal, waits for it to come back. That takes 2 seconds. They chart down all of this information for the amount of time that it takes. Then what they do is they go ahead and calculate the depth at each location. So at location A, what's our formula again? How much time did it take for at location A? 1 second. What's velocity? We already have the number for velocity though. What is it? What's the speed? 1,524 what? What's 1/2 of the time?
25.
What's the distance at location A? You should be able to figure that out without a calculator. No, I'm not giving you a calculator. How are you going to figure that out? Divide it out. That's simple division. Divided by 2. You can do it without a calculator. 762. 762 what? Is it meters per second? You just told me that depth is measured in meters. The seconds canceled each other out. Depth is measured in meters. Guys, is this a second grade class? No, what grade is this? 8th. And you were begging me for a calculator to figure out simple division right here? Really? No, you don't need. That's the problem. When you're in the grocery store and you're trying to figure out how much change you're going to get back, you're going to use a calculator. You're going to be saying, okay, I gave this person $15. The bill was $14.96. How much did I get back? Let me get on my calculator. I don't think so. Yeah, that's simple, and so is this. Yes, it was. You can quickly divide 15 divided by 2. You know. Come on, really? Yes. All right. So now that we have this information, they would continue on plotting through all of their locations. So I'm going to break you up and just, not break you up, but just give you a specific location. And in that space below, you're going to find out what the depth is for just your location. So this group here, you're going to figure out location B, C, D, E, F, G, H, I, and J. Go ahead and do that now. It's your location.
Yeah, you try to get up. You got it. Like, yeah. Okay, here we got.
Now some of you may need a calculator because of some of the numbers that you end up there. What do y'all have?
We got J. We got E.
We got B.
We got E. We got E. Oh no, we got E. Yeah, we just have to. You don't have to do all that.
All right, so you should be able to have your answer with the simple math. We've already figured out location A being 762 meters. Location B, what do you guys have? 1,524 meters. Location C. 1,016? I don't think that's right. Just plugging in the numbers, guys. Location C was 1/2 of 3 seconds times 1,524. What did you guys get? 2,286. Location D? Location E. Good. F. G. H. I. And J. Make sure you fill in your numbers in your blanks on your location so that you have your plotted data. Everyone have this? Okay, well, I'll wait for you to get it, but if you flip your papers over, and I'm going to come back to it for just a second, you will see a graph like that. In a moment, we're going to graph it. And what do you think we're graphing? The depth, and what do you think we're going to end up with? Let's see. The ocean floor. Okay? Everyone have it? Quiet, quiet, quiet. Okay? In graphing it, this is where your math skills come in. What does this top area represent? This is sea level. So what number should go there? 0, because there's no depth here. No depth. We're measuring how deep something is. So when we start to go down this axis here, are we lowering in number or are we higher in number? We're higher in number because we're seeing, okay, is it 1 foot deep, 1 meter deep, 2 meters deep, 3 meters deep, 4 meters deep? We're trying to see how deep it is. So we're going higher in numbers. So what goes on this axis? The what? The depth. What goes along this axis? Remember, your boat is traveling and stopping at, which are called the locations. These are going to be your locations. So if you want to draw yourself a little boat here, that's perfectly fine. So what's all of this graph area considered? The what? The ocean. That's the water. So inevitably, you're ending up with something like this. You have your locations, and then you have your plotted depths. Now, we have a range of depths. We have depths that go from 700 and something down to 6,000 and something. So therefore, I just plotted it like this. You can use the same numbers. You don't have to. I just skipped random amount of spaces or every other, and then I jumped through like that, just so that we can fit it on our chart. It's perfectly fine how you do it. So let's quickly then go ahead and plot it out. All right, so at location A, how deep? Before we hit the ocean floor, how deep was the ocean floor there? Location A. 762, so somewhere around here. At location B, first of all, this was what? 0, because that's sea level. Make sure you label that sea level. All right, at at location B, what was the depth? 1,524, so we'll just say about there. Don't wait for me to plot it. You start plotting it, because your graph doesn't look exactly like mine. Just start plotting it. You don't need to watch me plot. You've done this in math before. This is 8th grade. Location C, where is it? What was it for location C? 2,286. Location D? 6,096. E? 4,572. F? 3048. G, 1524. G, H was the same thing, and I was the same thing. J, 762. So then you have to connect the plots from location to location. We're going to start at sea level because that, I'm sorry, at the coast because that's where your boat had to start, and you just connect them with the line graph. Now, basically, if you look up here really quickly, this is considered the what? That's sea level, that line there, but this area here is considered what? Land, which is the coast. And the boat travels from coast to coast. All of this here is what? This is your ocean floor. What could we say this, oh, that's not big, that's big. What could we say this area is, a feature? That would be your continental what? Shelf. What's this? Your continental slope. What would you say this is? I wouldn't say that's a valley. It's probably a trench. Looks like a trench. Some features are not evident here. This is another coast, so therefore this would be what? Shelf, and this would be the slope. Okay, good. And you have a question. Go ahead, Janda. This is just a graph. Remember, it's a two-dimensional picture representing three-dimensional. So it's just a graph. Graphed it out. Any questions about this? Okay. Then you have a blue piece of paper in front of you. I mean to do this. You have a blue sheet that looks like this. I want you to go ahead and put that sheet the long way. Your blue sheet of paper. It doesn't matter if the holes are at the top or the bottom. The long way. Portrait. Landscape, not portrait. Okay. Where your holes are either at the top or the bottom. What we're going to do is the ocean floor is not the only thing in the ocean. What else is in the ocean? Marine life, right? So we're going to talk about marine life. And on this paper, this is what we're going to use to talk about it. On this side, we're going to take just a couple of notes. So let's label it life in the ocean. And these are your notes. Now, your marine life is grouped based on a couple of things. Who can tell me what they think marine life, how marine life is grouped? Okay, that's a possibility, but size is going to depend upon something else. Okay, species is going to depend upon something else. So we have two basic categories. Okay, and that's going to depend on something else as well. That's also going to depend on something else. That will also depend on something else also. Where they live. Where they live is going to determine their bone structure. That's going to determine what they eat. What else do you think it's dependent upon? There's two things. So basically, they're grouped by where they live. If they live in this area, that's the group that they belong to. They're also Why are we, well, how do I ask this question? Let's see if you first can think of the second category. Behavior meaning what they do things. Like us. We live on land because how do we move? We walk. And fish live in the water. That's where they live, and then how they move. So we group them based on these two things. In addition to this, there are three kinds of marine life. And the three kinds of marine life are grouped because of where they live and how they move. One kind of marine life is our good old plankton. And plankton drift or float. That's how they move. And that's why they're considered plankton ones. Then we have two types of plankton. We have phytoplankton, which is the type of plankton on SpongeBob. And what do you think phytoplankton is what like? What word do you see in there?
They like to fight.
Well, that's not F-I-G-H-T. What word is that similar to? Photosynthesis, which is what? The making of food. And what can make their own food? Plants. So phytoplankton is plant-like. Then we have zooplankton. And zooplankton is what like? Animal-like, because of the word zoo means animal. Another type of marine life, which again is categorizes this because of where they live and how they move. Then we have nectons. And nectons swim. They don't drift or float, they actually swim. And thirdly, we have benthos. And benthos live on ocean floor. So B at the bottom. And then the last thing that we're going to write for this marine environment zones are affected by, they're affected by two things. You have three zones of the, well, four zones of the marine area. And those zones are going to be affected by two things. One thing that's going to affect the zone of the marine, the water, is the water depth. Water depth is going to determine what zone it is. It's also going to determine what's going to live there. And the other thing, so this is a combination, is sunlight. The amount of sunlight. So sunlight amount. Any questions? So far, so good? All right, so if you flip your paper over to the other side, you now have an open, what? Area. This is an open ocean. Up here, at the very top, is going to represent our what? Well, let's first do this. First, we have to start off with some water. So go ahead and give yourself some water. What's in the open sky? Your sun. So make sure you get yourself a sun. At the edge of the water, we usually have what? A what? A beach or a coast. So make sure you give yourself a beach. And then all of this area here is what? All of this brown area is what? That's your ocean floor. You can always color that in later, but I'm going to move on now. All right, so far we have our scenery for our ocean. Everything under here is the water. All right, moving on. This area here is called the Intertidal Zone. Why do you think it's called the Intertidal Zone? Why do you think it's called the Intertidal Zone? These are where your tides come. Sometimes the water could stop here. Sometimes it could stop there. This could be considered dry land, or over here could be considered dry land. Sometimes the water could even come way up here. This is your intertidal zone. It's within the tide. Inter means within. You don't need to write down the extra information unless you can't remember. This is the purpose of drawing the picture, because if we draw the picture, you can see it happening there. Any questions so far? Do we notice that this is near the coast? Right? We don't need to write it's near the coast because we can see that, correct? So this is definitely going to be near your coast. Can the things change here? Can the environment here change often? Why? It could rain. Why else? What's happening there? Because of what?
Water.
You got waves.
Water.
What also goes up and goes down? Your tides. So you can have low tide, you can have high tide. There could be one moment if you live in water, you may have to relocate by tomorrow because there's no water there. So if you were a certain organism that lived there, you may have to move on a constant basis. Guys, we got to pack up again, honey. Get the kids. We got to go. We got no water here. We got to move. It's like, this guy is so unstable. All right? Okay, so let's talk about some of the organisms that live here. I'm not going to draw all of them. You can draw whatever one you feel like drawing, but I'll mention some of them. In this area, in intertidal zone, you have stuff like seagrass. You have things like periwinkles. Those are your shells that look like that. In this area, you also have things like snails. There are herons that live here. So a heron would be all right. You also have here things like Patrick would live here. This would be your starfish. Floating on the water. Conches, and I used to have my conch shell here from Bahamas. That would be there. Yes.
Thank you.
You have your starfish would go here. In this area, you also would have things like Mr. Krabs. So, based on the SpongeBob show, can Mr. Krabs and Patrick live at the bottom of the ocean? No, they can't. They won't survive there. They don't move in that way. They live in the intertidal zone. So that's the irony of SpongeBob thus far that the author, the person who wrote it, put in there because he's a marine biologist.
So, were they talking about where SpongeBob lived that big foot that like sloped really down? That was the whole point. They can't go down there.
Right. All right. The next zone you have is your Neuritic Zone. That's in this area. In the Neuritic Zone is where you have an abundance of life. It's going to be a lot of life there. So what do you think is going to happen there? What do you think us humans are going to do? This is going to be the area where we are definitely going to be doing a lot of fishing. So we're going to be doing a lot of fishing here. And in this area, there are various different types of life here. Here you're going to find, in the Neuritic Zone, you're going to find lots of fish like your colorful fish, which would be who am I drawing? Nemo. So we got our colorful fish there. In addition to our colorful fish, dory would be there. Dory's a colorful fish. She would live in that area. We also have Plankton lives in this area because he floats. Sponges live in this area. SpongeBob lives here. Jellyfish live in this area. So again, can SpongeBob live down below? Can Plankton live down below? Now, plankton will drift in this area. He will also drift in the intertidal zone, but basically floating along this neuritic zone. Here you also have seaweed. The neuritic zone is close to your continental what? Shelf. So this is far out. We won't swim out there. This is where we'll fish. We'll stop swimming somewhere along where this first arrow is. That's far enough out for us. Even though it looks shallow on the picture, that would be considered really deep in the real world. So it's near the continental shelf. You have your seaweed. You also have sea turtles. Here you'll have dolphins will also live there. So Mr. Krabs' daughter lives in this area. What's her name? Pearl lives here.
She's a whale.
She's a whale? Okay, no, she won't live here. Sorry. Pearl won't live here. You have dolphins that live here. In addition to this area, you'll have things like corals. That's why the colorful fish are there. The next area that we're going to talk about is the oceanic zone. This is also known as your open ocean. This is far out where your cruise boats are going to be out at. And in this area, this is going to include even more plankton are going to float out here. Zooplankton and phytoplankton. What eats plankton? They swim with their mouths open. Whales. This is where you will now have pearl.
That looks so small.
I know. But it's a whale mouth. This is a whale. That's a well. And there's a blowhole up there. Okay. Whatever. That's a well. You also will have this is a squid, but Squidward is not a squid. He's actually an octopus.
He is?
Yes, he is.
Why is all slow?
That's the irony. 1, 2, 3, 4, 5, 6, 7, 8. He has 8 legs. He has 8 legs. 8 tentacles. Squids don't have 8 tentacles. He's an octopus. That's the irony. He's not a squid. He's an octopus, but we call him Squidward. In addition to that, we also have sharks. Live here. And this is going to be the best shark you've ever seen in your life. Everybody get out, the shark's coming. It's a scary shark. And then you are going to be surfing in this area, in the intertidal zone area. That extends out. You won't go well in the neuritic zone. That's too far out for you. Who's Larry?
Yeah, Larry the lobster.
Oh, lobsters are over in the intertidal zone also.
He is?
Oh, Larry, yeah. That's how we catch them.
And we're Sandy Cheeks.
Sandy is one of us. So she lives on land. So then draw her on land.
Which?
Lastly, we have the benthic zone.
Bikini bottoms like in like
This is where Bikini Bottom is. It's in the big zone, in the benthic zone, because it's the bottom of the ocean. Those other organisms can't be down there. Why? Is it light down there? No, it's very dark. In fact, your neuritic zone is going to be the zone that's going to get much sunlight. That's why your plankton will thrive there. That's what's going to happen there. Your benthic zone is very, very dark down here. This is your dark water. Yes, that is definitely going to live down here. Uh-oh. I mean to do that. This is your anglerfish. Why does it need that light? Because it's so dark down there. In addition to it being dark, guys, it's also what's the temperature? Cold. It's very cold. So, yeah, it had to adapt. Was born for adaptation of where it's going to live. It's very cold down there, so organisms that live there have to be able to endure cold. They also have to be able to endure dark. They also have to endure high what? You go deep, deep in the water with pressure. It's very salinous down there. What do I mean by salinous? Salty. And if it's a saltwater area, but if it's not, then it's an area with just stuff in it. Stuff's going to sink to the bottom, and it's going to sink to the cold area. That's where it has all your particles. In addition to that, here's where you have like urchin and sea worms. Down there. Yes. Yes. Good point. Listen up. Just because these things are in this area, that's where they live. That's mostly where they hang out. Does not mean they can't swim to another area. There's been times where sharks have come to the Neuritic and the Intertidal Zone and attack. Not really a shark attack because they live in the water. We are intruders and trespassers when we enter there and they attack us. 1 second. In addition, your Nemo could be found in the open ocean because he wandered, because he does swim. They don't just say, oh, that's where my cutoff is. Can't go any further. They do swim and they do float. We found octopus and squid on land. So they float, but these different areas are where they thrive at. That's why we have them there. Question. Two. Land sharks. Oh, sand sharks. Yeah. All right, so you should have had your picture nicely drawn. And this concludes this lesson. Actually, there is one more thing that I needed to mention, and that's the fact that we fish and we gather things from the water. We live on land, so we're called what type of life? Not just us, we're talking about bears and birds. We are called terrestrial. Because terrestrial comes from the word terrain, which means land, earth. So when you say extraterrestrial, that means out of this earth. When you're talking about aliens, your relatives. But terrestrial means land. That's why when you get a lizard or a snake, you buy a what? Terrarium, not an aquarium. So we are terrestrial. When we fish, we're getting what? What are we getting? Fish from where? The ocean, also known as the aquatic area. So this is terrestrial aquatic relationship. That's what this represents here. Terrestrial aquatic relationship. The fact that life on land is gathering food from marine. Give me another example of a terrestrial aquatic relationship. Think of relationship where land creatures get food from water creatures. Bears doing what? Don't ooh, you're not second grade. Bears doing what? Bears catching fish. Good. Seagulls catching fish. Pelicans catching fish. Very good. So be able to recognize a terrestrial aquatic relationship. Now this officially ends the lesson.